Yes. So here what we discussed that if this particular PC is trying to ask to this PC only regarding the MAC address instead of asking to the default gateway. And in this case, what will happen? No, that this particular device will ask the MAC address information to this PC. Okay, but who will reply? Default gateway will reply. This concept is called as a proxy ARP. Okay, so note down this point. That when a PC wants to communicate with PC located in different network, for that it generate ARP request and asks the default gateway MAC address information. And in this case, the PC receives the MAC address of the default gateway interface. Okay, not the MAC address of the destination PC. And this process is called as ARP, not proxy. It means the concept says that it depends upon that particular PC is asking the MAC address information whether to the default gateway or to the PC. Based on that condition only, it will be the proxy ARP or not. Fine. When PC considers that, see, I'm writing here only PC, you can consider all the end devices, right? So when PC considers that the destination device is in same network, but actually it is in different network. In this case, PC asks MAC address information directly from the PC instead of asking to the default gateway. But in this case, router reply with MAC address of the default gateway interface. And this process It is called as proxy. Fine. Understood the concept? Now see here what happens and what is called as a packet forwarding and packet flow. See, when you are trying to reach from this device to this device, so it involves all the steps and different process. The steps include first to identify the default gateway, then to generate an ARP request, send ARP request, get ARP reply, then send IPNC ICMP echo request, echo reply. All this process will be included, right? So in this case, what all the steps is required? First, you need to find the interface also. With what interface the data has to exit. Next, what is my default gateway? Next, what is my destination address? All these things. So all the steps that is involved in sending and receiving the data packet is like a packet forwarding. The individual steps called as a packet forwarding. Whereas packet flow is the entire journey of the packet. Okay. What is packet forwarding? Packet forwarding is a process or the steps that was followed to forward a packet from a source to a destination. This is all the individual steps. This process will be called as packet forwarding. Now, once the forwarding has been taken place and it is going to show you the entire journey of the packet, that what all the process it has and what all the devices it has crossed to reach that particular destination, this is called as a packet flow. In a single line, you can remember that packet flow is the entire journey of the packet. Okay, this is a difference between packet forwarding and the packet flow. See, what is written in this? It says that packet forwarding is what is a process by which network devices such as routers or switches transfer data packets from one interface to the another interface based on what? The packet destination address. Right? So its goal is to ensure that packets are directed along the correct path to reach a particular correct destination. Right? Now, as you know that if my destination is in different network, so routing will be required. If destination is same network, then routing is not required. Apart from that, if let's say once routing has been done, and even you have implemented their access control list, where you are denying or permitting the particular types of traffic, in that case also certain like based on the policies, traffic will be forwarded. So this is all the steps includes here, where it is going to check routing tables, where it is going to check access control list if it is implemented. All this process will be called as what? Packet forwarding. So it involves what? It involves the decision-making process for sending a packet to the next device. Now you know that is in our scenario here, what is happening? That just we have taken here only one router, correct? No. Here I have only one router. Then I have PC. Now there can be a situation where I may have one more router. In that case, my responsibility to send this packet to this one. Now between them, routing will be done and then they will be sending the packet to the next device and further it will follow to reach the destination. Okay, so all this process is involved here, right? So you are identifying the source device, destination device, even you are finding what? Intermediate device and what you are doing, the routing between the intermediate device. So this process will be called as packet forwarding. Now what is packet flow? It is the sequence of steps or processes that a packet undergoes at it travels from its source to a destination. Means it gives you the information regarding all the sequence of the devices that it is going to cross to reach a particular destination. That's why it says here that it encompasses the entire journey of the packet, how it is created, how it is transmitted, how it's routed and received across the multiple devices. Okay, so it involves sequence of the packets exchanged between the source and destination, and it is identified by source IP, destination IP, source port, precision port, and protocol. It means it is giving you the multiple all the information regarding the means to reach a particular destination that particular packet has taken. The source address, destination address, if any port number, or if any routing protocol has been used. Right now, so here it is showing you the differences between that. See, packet forwarding and packet flow difference. So packet forwarding, it will give you the information within a single device. Okay. Whereas packet flow is what? Across the entire network path. That's why it is entire journey. Now, in this case, decision making process of where to send the packet, where to send the packet. And this is what end to end journey of the packet, right? So in this case, I told you know that, okay, find that if I need to have one more router here, and if I need to send from this PC to that PC, so I will be having one default gateway. Next, between this router and this router, how this packet will flow will be done with the help of what? One routing protocol. Okay. So here, if this router is checking, if I need to forward this packet to next device, what steps I require, this is called packet forwarding. Whereas this PC, this switch, this router, one more switch, one more PC, all this information is coming and it is showing you to reach a particular destination. It is called as a packet flow, right? Got the point? Got or not? So in this, it is telling you routing, switching tables. In this, multiple forwarding decision. In this, it says what layer 2 switches or layer 3. So layer 3 devices are the examples. In this, all the OSI layer will be the examples. It is device centric. This is network centric. It is based on network. Then in this example, it says that if router sends a packet from this interface to that interface, but in this case, packet travels from this PC1 to PC2 across routers, across switches, all the process. In this, it is concerned with what? Outgoing interface selection. Means if I need to forward this packet, with what interface I need to send that. So what is required? Interface selection will be there. But in this, how packet behaves and changes at each stage, that is the example of the packet flow. Correct? No? Got the basic idea? So what we can conclude here, packet forwarding is the steps involved to forward the packet from source to destination. Examples can be identifying the outgoing interface to forward the packet to next device. Whereas packet flow, it is the entire journey of the packet where it involves the information regarding the devices and process that has been involved to forward the packet from source to destination. Clear? It's clear. Now we'll see these steps, like how proxy ARP and ARP is working, right? So for that, we'll do all the configuration on the EVNG. So for that, I will open the EVNG. So first we need to go on the virtual machine and see here we have EVNG, power on the virtual machine. See here you have received one IP. So based on this IP only, we have to access that. So first add new lab. Let's see, we want to see here ARP only or layer 3 forwarding. So save this now. It is there, that's it on the now again save. Now to take the device, just you right click, come to this node. Now you search here VIS router it is. Now I want to take one router. So just save. See, single device is going to consume 1 GB RAM approximately. Okay. So one router. So let me edit. This is a router. Next, we'll take here switch. We need to take here two switch. Okay, these are the images of the devices that is present. And these are the icons, like how you can change also everything. Then if you want to take here 2, then you need to write here 2 number of nodes. Next, save this. Now again come to, and now if you will check here Windows PC, then see your single Windows PC is going to consume around 4 GB RAM. Okay, so instead of taking this, we will be taking here VPC, virtual PCs. So we may take here, let's say 3 virtual PC. So 1, 2, and 3. And this is PC1, PC2, just 1 minute. So this is PC3. So like only today I will be showing you how to connect all those devices and everything. Because if every day if we do, so it consumes time, right? So I will be having ready-made topologies every day. Now come to this text 192.168.10.1/24. This is 10.2. And then right click, duplicate. This is 10.3. And this is going to be 20.1 and 20.2. Now more action, start all nodes. Then come to this router. This PC1, this PC2, and PC3. So I will be using a MovaXterm for configuration purpose. You can use putty also or mobile stub also. Anything is fine. Now come to this PC and assign the IP 192.168.10.2, right? /24. Then come to PC2. IP is 192.168.10.3/24. Then come to PC3. IP is 192.168.20.2/24. I have not given any default gateway on any of the PC. Okay, now come to this router. First give no, and then you come to check IP on the PC1. So show IP. So this is the IP. Okay, default gateway is not present. It is means unknown it is. Now come to this router. Enable config space T. Now interface we have 0/0 visible in the background. Interface G0/0. What is the IP address? Is 192.168.10.1, then 255.255.255.0, and give here no shut and give exit. Then we have one more interface G0/1. IP address is 192.168.20.1 and 255.255.255.0, and give no shut and give exit. Then do show IP interface brief. Configure the IP. Fine. Now you come to this PC1 and try to ping to the same means network PC. So for that, just we'll try to capture. So we'll capture the packet using Wireshark. Now you see what happens that if you try ping to 192.168.10.3, PC is in same network. What will happen? It's pinging, right? And check in the Wireshark. What is first? What is it in? Broadcast. What it is? R who has 10.3 tell. Who is asking this? 10.2. Now it got the reply with at MAC address. That 10.3 is at this MAC address. Now, if it is receiving the MAC address, then what it says? ICMP request, ping echo reply, right? Then it get what? Echo request. So ICMP here, what is the type of message we have? Type 8. Type 8 means what? Echo request. What is the code we have? 0. So type 8 code 0 is what? Echo request. Now type echo reply is what? Type 0 code 0. It is what? Echo reply. Clear? And if you will check the app request, yeah, opcode request is what? One, this is the sender MAC address. And what is the target MAC address? All F. Fine. And target IP is written here. Now, even if you can see here, what is TTL value written? TTL is what? 64. What do you mean by TTL? Time to leave. What is it? Number of devices it can cross without being discarded. Correct? No? Fine. Now, it is able to ping to the device in the same network. Okay. Now, if you will try to ping 192.168.20.2, what it says? What it says? No default gateway find, right? Why no default gateway is there? Because we have not configured, correct? No? Where we will need to. Okay, let's configure the default gateway now. Come to this PC and give the IP as 192.168.10.2/24 and gateway is 192.168.10.1. Configure gateway written 10.1. You can verify also. So IP, what is telling you that this is a gateway present, right? Okay. Where we should capture the packet? If we ping, come to this PC, try to ping again 192.168.20.2. Fine. Yeah. See what is written. To whom it is asking. See that line. It is asking to 192.168.10.1. Right? Who is asking this? 10.2. It means this question is being asked to whom? Default gateway, not to the PC. It is not asking to the PC. It is asking to the default gateway. And what is it is called as ARP only. Correct? No? Because it is asking to the default gateway only. That's why. And what it is showing you? Request timeout. Request timeout is what? It is unable to reach. Request time is what? It is sending the messages. It knows where to send, but it is unable to receive any message from the destination device. Now, why it is not able to receive any information from the destination device? What could be the reason? If you will observe, we have configured default gateway on the PC1, but we have not configured any default gateway on the PC3. If PC3 has to send any traffic, then what is required here? It also need to have a default gateway. Correct? No? So now we'll configure the default gateway on the PC3 as well, and then we'll try to see. show IP. So IP is 192.168.20.2/24. And then what is the gateway? 192.168.20.1. Show IP configured, right? Now come to PC1. Before that, we'll capture the packet. Capture on which interface? 0/0 only. Pinging. Again, what is received? R. Now it is again asking to whom? 10.1 only. Why it is showing you here? Because this interface has received that 0/0. Now when it will receive, it will reply. So what it says, the 192.168.10.1 is at which MAC address? This one. But this is the MAC address of what? The router's interface, default gateway interface, not the PC interface, PC MAC address. Right now, so this process will not be called as a proxy app. It is also showing you that this is a ARP only. Understood this concept? Now, what happened that once when we have given the command as no default gateway, so in that case, it was giving you no default gateway found. But in actual scenario, if you try to ping, it will show you what? Destination host unreachable. Then if we have given the default gateway on one side, but it is missing on the other side, then it gives here what? Request timeout. Okay. So we need to understand that in which scenario we will be getting the output as destination host unreachable, and in which scenario we will be getting the output as request timeout. Okay. See here. What is it? Request timeout. So it shows you the multiple reason where we can get the output as what? Request timeout. Now this occurs when, what it says, this occurs when your device sends a request like what? A ping to a destination, but it did not receive a response within a specified time. If it does not receive any response within a specified time, then what happens? You will get the output as what? Request timeout. Fine. Now, what could be the reason of this? The reason is network congestion. If too much traffic is there, then it could be possible where response is not coming. Fine. Now, the destination network devices blocking the ICMP request. Let's say firewall rules preventing the responses. It means here what happens? That request you will be sending, but you will not be able to get any reply. In this process, you will get the output as request timeout. Now, one more reason it is telling you that slow or unresponsive destination where it can be possible where server might down or where device or interface might down. Correct? Or packet loss because of unstable connection is there. Now, among this also we have now only verified there that there could be one more scenario. What is our scenario? That default gateway not configured where? On the destination device. In this case also you will be getting here request time. Okay, these are the multiple reasons. So there can be a question that if you are being asked the questions based on the ping, so it can be like when you ping, sometimes we get request like output as request timeout. So what are the scenarios in that we will be getting this, or sometime we may get as a destination host unreachable. So what are the scenarios where we will be getting as destination host unreachable? Okay, now then even destination host unreachable, it shows that this will be getting that this error means your device knows that destination should exist, but there is no any valid route to reach it. Means it knows the destination network that I have to reach there, but it does not know how to reach there. Now, what could be the reason? If there is no routing between the source and destination, if there is no default gateway, right? No, these are the multiple reasons. If there is no default gateway, in that case also we'll receive destination host unreachable. If no routing, in that case also we'll receive this. So what is written here? Misconfigure network settings or wrong gateways. It means one more scenarios can be there where wrong gateways are there. Or a routing issues. A routers between you and destination does not know how to forward the packet. Then device or network failure. Let's say you know how to forward. For example, if I'm having a router, I am having a switch, I am having a PC here. This side also one router, this side a switch, and this side I'm having a PC. Now, in this case, if this PC is having the default gateway information, it will forward this. Now, it is also having the interface information, it will forward. But what if network failure is there in between this? It means that it is sending it, right? But it is not forwarding it. Again, it will not be able to reach here. Then again, the possibility is that here we will be getting the output as destination host unreachable. Correct? No? And now if it is pinging, then 100% it will ping. Now, if there is certain, whenever you try to ping, so if it is not 100%, it shows you 80% or 60%. It means what? That here the packet is lost in ARP. It is lost in the ARP only because it is going to see everything is happening in the background. When we are doing this debugging or when we are going to capture the packet, in that case, we are seeing it separately, ARP and ping. But in the real scenario, what happens? It goes it one flow, right? In that case, in the background, it happens and it does not show you the separately ARP and ping. And that's why it is going to show you the loss in the packet, certain loss. Is it clear till here? So just we'll write all the conclusion point. First thing, what is ICMP? Internet Control Message Protocol. Next thing is, what is the protocol number of ICMP? One. Protocol number is 1. Now, ping comes under ICMP. What is ping? Packet Internet Dropper. Dropper means to search anything. Okay. It is an utility that is used to check the reachability and connectivity between the devices. Now, to verify that, it sends what? Echo request. Echo request, how you identify? Type 8 and code is what? 0. Then what we have? Echo reply. Type is what? 0. Now, if your host is not reachable, then if destination host unreachable, then you receive type as type 3. Just 1 minute, let me solve. Hmm. Echo request type 8, echo reply type 0, unreachable type 3. Type 5 is for what? Redirecting the packet, and time exceeded type 11. Done. So if the sender device sends ping message and does not receives any reply, then it shows output as request timeout. It means it knows the valid route to reach a particular destination. It knows or it have the valid route to reach the destination. Now, if sender does not have a valid route to reach a destination, then it gives output as host unreachable. Clear till here? Now, what is this packet routing? Packet routing is like it says that packet must be routed between the two devices when they are on the different network. Now, it says that as the data is encapsulated here with its IP address, so it detects a destination is on different network. Like it's telling you that as data is having the information that I have to reach a destination IP, and this IP is in different network, then it must be routed. And for that routed purpose, routing is required. So the device checks what? For that, it checks routing table, right? To identify its next hop IP address. Now, for that, it can know about the next hop IP address from the different methods, from a static routing entry, now a default gateway, or routers can learn from the different routing protocols. So one thing you need to remember here that in the case of routing, apart from routing protocols, one thing is very much important that is called as a default gateway information. If default gateway information is missing, then that particular device will not be able to send the traffic outside its network. You can consider that this default gateway will be acting as what? It is acting as a entry and exit point for a data on a network. And based on this default gateway only, we are going to get the information that they are in the different networks. Now, if you are like having a router and you know that router has multiple interfaces, let's say one interface, and like this one interface. So each interface will be acting as what? A separate default gateway, right? This is one default gateway, this is one default gateway, and this is one default gateway. Clear it is? Now, as you have done CCNA, so what we can do one day that when you come to class, so you need to own these devices, right? Okay. And we'll try to configure this and we'll do this routing on this also. But not tomorrow, but once we are done with the static routing, then we'll do. I will not do, you all will do. Okay, fine. So I will inform you on that day that this rack should be on. Okay, fine. Till here it's clear now? See what is written? That in a packet contains a destination MAC address that is not in the switch MAC address table. Means the destination MAC address is not in a switch MAC address table. For that, it sends, it is going to ask. For that, it is called as what? Unknown unicast flooding. That's why I told you, not as a broadcast message, the actual term is unknown unicast flooding. Now here you found one term. Encapsulated. What do you mean by this term encapsulated? Tell me. What do you mean by the term encapsulation? Adding what? Adding what? So encapsulation is only header and trailer. So like we can say that encapsulation as adding. Adding what? The additional information. What type of additional information? Like MAC address, IP address, port numbers, all these things. It means that when data moves from layer 1 to layer 7, what happens? At each layer, it gets extra information. It means example MAC, example IP, example port numbers. Now this is called as encapsulation. Then what is decapsulation? Opposite of this, decapsulation means removing this additional information. Now, in which direction it will happen? Like when data moves from layer 7 to layer 1. So at layer 4, it will be having port numbers and source port and destination port. When it moves to layer 3, port and destination port number removed. When it moves to layer 2, IP will be removed. When it moves to layer 1, MAC address removed, like that. So removing the additional information, we can say. Clear till here? Okay. Now, in which layer fragmentation happens? In which layer fragmentation takes place? In which layer fragmentation takes place? Anyone from online?
Transport layer, sir.
Transport layer. Then in which layer segmentation takes place?
Network layer. Maybe
Huh?
data packets inside. Network layer, sir.
Network layer. Segmentation, network layer, fragmentation, layer 4.
Uh, Transport layers.
Segmentation will take place at transport layer. That is layer 4. Whereas fragmentation will take place at network layer.
Sorry, sir.
Got the point? Now you tell me, what do you mean by the term fragmentation? Dividing the data into the multiple data packet. This is a definition of fragmentation, correct? But when it required to divide the data packet into smaller segments or into the smaller fragments, when it required, when the size exceeds it, what is the size that should not exceed? Hmm? What? Maximum MTU. That is called as what? Maximum transmission unit. What is the value? The maximum value is 1500 bytes. It means that at any point of time, if my data size is more than 1500 bytes, then what is required here? Fragmentation is required. Correct? Means dividing the data into small fragments so that it can be delivered. Now, you know that if it is delivered, then fragment offset will be required to reassemble that also packet, to reassemble the packet, data packets. This is called as an MTU value. This MTU consists what of the information? Data size plus header information. Now, what do we mean by this term? Data size means payload. And here it what contains? What header? IP and TCP header. Now, what is the maximum and minimum value of the IP header? 22. What is the maximum and minimum value of TCP header? 20 to 60. It means that this is called as a maximum transmission unit. If I remove this header information, what I will get? What I will get? MSS. This is what? Maximum segment size. What is the value? 1460. What it contains? Only size of data. It means MTU will have two information, means do not two, multiple three information. Apart from one, we have data size, one we have IP header size, one we have TCP header size. Then MSS is going to have only one information, data size information. And this is called as a maximum segment size. Then there could be a minimum segment size also, like we can call as a payload. So what is the payload size? Now you know what is payload. Payload is the actual size of data. What's the value? 46 bytes. Okay, this is the actual value. Now, tell me what is the minimum Ethernet frame value? It means that it is going to contain what information? Data plus again header information, and it is going to be 64 bytes. Clear? It's clear? All the points? Then one last thing I will show you, GR. Done till here? See here what happens and what is GR. Don't worry, I will share you all these things. Whatever I'm writing, it will be shared to you. IP is 10.0.0.8/8. Then capture the packet. Come to second PC. IP is 10.0.0.8/8. What is it in? It is being used, right? What it is? What it is? Gracious ARP request for 10.0.0.8. In what form? Broadcast form. Who is going to generate this? The same device. Like where I'm going to create a duplicate IP. Right? So why do we have this Gracious ARP? It is used to detect the duplicate IP address. See, Gracious ARP for IP, duplicate use of IP has been detected. Correct? Also in use by whom? In the MAC address of the particular device. It is showing you that this device is already using this particular IP. Okay. So in that case, whenever you are going to have duplicate IP address detection, so GRP will be used. Apart from that, why we use GRP? Whenever there is any change in the network, in that case, that change has to be updated to all other devices in that particular network. For that, GRP is responsible. GRP does not require any request from any device. Now, in a normal ARP, it always requires a request, and for that request, we get the reply. But in the case of GRP, there is no any concept called as a request. Whenever there is a change, automatically request will come. Correct? No? So GRP is used to detect duplicate IP address and it is also used whenever any change is there on any device and that change has to be updated to all other device in the network, and for that it generate ZR. ZR will be in what form? Broadcast form. It does not require any request. Okay. So today we have discussed about packet forwarding, where we have seen layer 3 forwarding. Then we discussed packet flow, then ARP, proxy ARP, ICMP, echo request, echo reply. What is the differences between request timeout, this is most unreachable, then GR. Tomorrow we'll start with the static routing. So we'll stop the recording for that.